Welcome back. My name is Darren Thomas, and I am the Director of Educational Research Techniques. In this particular video, we're going to be looking at how to do fraud detection with Python, but we're going to automate the model tuning. In other words, we're going to automate how to adjust the various parameters we're using in order to improve the performance of our model. So let's go ahead and see what we can learn. All right, so I'm inside Jupyter here, and I'm just going to start by, of course, loading all of my various libraries that I'm going to need. So we're going to be using the random forest classifier. That's in our first line. Then we're going to split our data. We'll talk more about that later. Of course, for our metrics, we're going to be using confusion matrix, classification report, and the ROC score. This is new compared to prior videos, and this is a grid search CV. This is going to allow us to find the best combination of parameters for testing purposes. And then, of course, we're going to need NumPy and Pandas in order to prepare our data. So let's go ahead and get started. We're going to run this. Now, my data, I already ran it before the video in terms of loading it into the environment. And I'm just going to print it real quick so you can get a quick idea of what we're looking at. The reason I ran it before is to protect where it's at on my computer. And so here's our data. We have about 30 variables here. Most of them are kind of like nonsense, V1, V2. This is kind of like dummy data with a purpose. And we're going to be using class here. This is going to be our dependent variable, our outcome variable, however you want to see it. And we're trying to find instances of fraud. So altogether, we have 7,300 examples or instances of our data here over 31 columns, excuse me. And so having said that, let's go ahead and prep our data. There's not a whole lot to do except we want to separate our independent variables from our dependent variable. This is standard practice when, of course, setting up algorithms using machine learning and data science. So in this first line here, we're grabbing all of our rows and we're grabbing columns, the second column to the 29th column. That's how it's set up in Python. It's not too intuitive, but that's how they do it. And then once we grab all of our independent variables, then we're going to convert them to an array. And then we grab all of our rows and column 30, or I guess you could say this is probably going to be column 31, sorry. And we grab our dependent variable, and then we convert this also to an array. That's all we're doing right here. Go ahead and run that. And after this, we're going to set up our train and test data. And so what we're doing here is we're setting up 4 different objects: X train, X test, Y train, Y test. And we're using the train test split function. We're taking our X and Y objects from the previous cell as our sources of our data, and we're going to do a test size of 0.3. That means 30% of our data is going to be set aside for testing purposes, and the other 70% for training. And then, of course, the random state is just where you set the seed in case you want to duplicate this analysis. Excuse me. So we're going to go ahead and run that. Now we're going to do some work to set up our model. So let me try to explain what's happening right here. All right. The first thing we're doing is we're setting up the various parameters that we want to explore. And so what we've done here is that the stuff in red that you can clearly see is the actual parameter. And then the stuff inside the brackets is the various values that we're testing for. So the number of estimators is like the number of trees we're going to create. And so we're going to have 2 different ways we're going to do that. One set that has 15 trees, the other set that has 30 trees. Max features has to do with the number of features you're going to use. And so, again, this is kind of convoluted here, but it could be based on the log or it could be based on the square root. Again, it calculates how many features to use based on the square root of something. Again, that's kind of beyond that's really technical. Max depth is how deep down the tree goes. And so we're going to have 2 different options here, 4 or 8. And then the criterion that has to do with the purity of the nodes. we're going to use two different criteria, Gini and entropy. So, I mean, you could multiply these all together to see the different number of models we're going to create. So it looks like here, 2 times 2 is 4, times 2 is 8, times 2 is 16. So probably 16 different trees with all these various combinations. So as an example, one model might have 15 estimators. It might use max features based on the square root. The depth might be 4, and the criteria might be Gini. And again, all the different various combinations. That's what we're doing here. In this next line, we are setting up our model. We're making an instance of it. So we make an instance of the random forest classifier, and we're just setting our seed for duplication purposes. And then down here, we're going to have our actual cross-validated model. So what we're doing here is we're using the grid search CV function. Our estimator is model. That's this guy up here. Our param grid right here is going to be this guy up here. Our CV is going to be 5. That means what we're going to do is we're going to separate our data, our training data into 5 folds. 4 of the folds will be used for training, and then the last fold will be used for testing. And then we repeat that process over and over. And we take the average to see how well something is doing, or how well our model is doing overall. And the criteria for whether our model is doing a good job or not is going to be based on the recall, which is one of the various metrics that are used to assess models during classification. And the n_jobs has to do with the processing power. So this is all the things that are going on right here. So this might take a little bit of time, maybe 15 seconds maybe. And so hopefully it's thinking right now. And we won't really know. It's not going to tell us anything when it's done. All right. And so now we're going to go ahead and we're going to see, okay, it's going to show us which combination of parameter values are best when we're concerned about recall. So we're going to go ahead and run this. All right. Now it's running. So it takes a few seconds. And so we're taking CV model. That's what we set up in the previous cell, and we're fitting it. And then we're calling best_params_. And here's our results right here. So when we're concerned most with recall, based on the parameters we were testing for, we should set criterion to Gini, max depth to 8, max features to square root, and number of estimators to 15. That is the best model in terms of being concerned with recall when considering these values right here. Now, it's possible that there might be a better model out there. We could play with the number of estimators, the max depth, etc. We could add other parameters into the parameter grid, but you have to think about processing power and the amount of time it takes to actually do this. Now, our data set is not that big, 7,300 examples, and we're only taking 70% of that. In addition, we don't have a lot of different parameters that we're trying to test for, so it didn't take that long. But if it gets highly extensive, it could be quite a while. And you also have to be concerned, even though we're cross-validating, you still have to be a little bit concerned about overfitting if you try to test everything and calculate everything. So you have to be concerned about that as well. Now what we're going to do is we're going to set up our actual model that we want to use based on the parameters that we have right here. So let's go through this nice and slow. So you can see right here, my criteria is set to Gini, just like the algorithm recommends. Max depth is set to 8. All right. Max features is set to square root. And number of estimators is set to 15. Now I do have other things going on in here. I set the class weights. This is a little bit trickier to test when you're trying to do the cross-validation grid search, a little bit trickier. But we're saying that if they misclassify something, the penalty is 12. Okay, so for a positive. So if it's positive, if it's classified erroneously as positive, the penalty is 12 times compared to normal. Minimum number of samples in a leaf is set to 10. So that means in a particular leaf or a node, there should be at least 10 examples, or 10 rows of data is another way to think about that. And so those are two that we kind of added in there. Then, of course, we're going to do things like we traditionally do. We are going to fit our model right here, as you can see. And then we're going to do our predictions with the independent test values, and we're going to get our probabilities. We need the probabilities for the ROC curve that we're going to calculate in a second. So that's all the good stuff right there. We're going to run this cell. Again, there's really nothing to look at, but we're getting closer. Now we're going to assess our model, and that should be the end of the adventure for us. All right, so we're going to get the ROC curve. That's the first thing you're going to see. That value can be anywhere from, I guess, 0 to 1. The closer you are to 1, the better the model is in terms of dealing with, true positives, false positives, and all those different things of that nature. And so we're going to take, looks like not the first column, but maybe the second column of the data for that, second column. Then, of course, we're going to have the classification report. That is going to give us our precision, recall, accuracy, and F1 score. Now, keep in mind that most of the time when you're dealing with fraud, the accuracy is going to be very high because there are very few instances of fraud. And lastly, we're going to have our confusion matrix. That's going to be our crosstabs of positive and negative values. And so let's go ahead and run this. So our ROC is almost 0.97. That's very close to 1. But this is kind of a relative score. So we'd have to compare it to something else to see how strong it is. But that is still pretty good. As you can see for our precision, you can see 0.94, 0.84 for recall, and 0.88 for the F1 score, which is a kind of an aggregate of precision and recall. So we're still struggling with recall. That's why, if you remember, we set our scoring metric for how well our model is to recall, because I knew in advance that was a problem. And so, in other words, we're having a problem with false negatives. So you can see we have 15 false negatives and we have 5 false positives. So the precision is reasonable depending on the context, but the recall is bad. Now, whether this is good or bad really depends on the purpose of the study and the context of it. So with the false negative, what we're saying is that this is not an instance of fraud when it really is. So if you're dealing with credit card, that might be a problem. People are getting away with this and we're losing money in that instance. False positives is we think someone committed fraud, but they really didn't. So again, that would hurt more on the customer side. If you freeze someone's account or you shut it down because you think it's fraud and it's not, you might have more of a customer service problem, which could lead to a loss of money. So this is where you have to work with your team and your leadership to decide, where are we willing to give? Are we more worried about false negatives or false positives? And how can we adjust the model to accommodate that? Because no model can deal with everything. And remember, as you keep working with your model, although we are using random forest and we are doing cross-validation, obviously when we are setting up our parameters, you can still start to strongly overfit to where your model only works really well with the data you trained it on. And so now what we're going to do is just kind of summarize what we learned and wrap up this video. So in this video, we learned how to automate selecting the values of parameters when you're trying to detect fraud using Python. And so, we loaded our data. We converted the independent and dependent variables into separate objects, and we also made sure that they were arrays. We set up our parameters. This is the new stuff right here. And then after that, after we set up our parameters, we did our initial model fitting, if you will. And it recommends these different values for the different parameters. We then put these values for the parameters into our model and then ran it and got the output. So we've done this kind of experience before for making general machine learning models. What's unique this time is that now we're kind of going through the same process, but in the context of fraud detection. And so what is really unique for us in fraud detection is the class weights. This is what's really new. If you've been watching these videos for a long time, all the rest of this stuff is kind of a review. But in our case, we are much more focused on the different class weights. They could be balanced or they could be weighted like this, so that we have a stronger sense of when we're misclassifying things. That is unique to this. So I want to thank you for watching. My name is Darren Thomas. I am the Director of Educational Research Techniques, and you take care.